All right, so let's go ahead and get started on chapter 7, chemical bonding. By far the best chapter, my favorite chapter, so let's start talking about it. So elements combine to form compounds through chemical bonds. And so naturally the question might be why? Why do elements form compounds through chemical bonds? Well, the answer to this question is actually the same as why does a ball roll down a hill? Right? If you place a ball on a hill, it's going to roll down. It's never going to roll up. It's not going to stay where it's at. It's going to roll down the hill. And it's all about going to a lower potential energy. And so the same thing, the elements do this. Whenever a bond is formed, it's because it's going to a lower potential energy. And what this potential energy exactly is a bit more of a complex topic. And that's reserved for 102 and thermodynamics. So think back earlier to the year, we learned about the 3 main types of bonding. And remember, the type of bonding is determined by what kind of compounds you have or what kind of elements you have in your bonds. So remember, we have this little staircase on our periodic table, and everything over here to the left is a metal. And then the stuff to the kind of upper right of this staircase is a non-metal. So let's take a look at our different possible scenarios. The first is an ionic compound. And so this involves the transfer of electrons. So something gains an electron and something loses an electron. And remember, it's with a metal plus a non-metal. Cool. Second type we can have is a covalent bond, which we stated was the sharing of electrons. And that's with nonmetals, right? So nonmetals with each other. And then the third type we don't talk too much about is a metallic bond. And metallic bond, what we say is that there's a sea of electrons. And this is basically multiple metals together. So think about the properties of a metal and a non-metal. One of the main properties of a metal is that it's easy to remove its electrons, while a non-metal, it's very difficult to remove the electron. So think about what you have when you mix this type of stuff. So if you have easy to remove electrons and elements with hard to remove electrons, right? One's easy to remove, one's hard to remove, and wants more electrons. So obviously the kind of conclusion there is that you transfer electrons, right? From what's easy to remove to the hard to remove things. If you have two elements where it's both of them are hard to remove the electron, right? Neither one of them wants to give up an electron. So the natural conclusion there is to share the electrons. And then finally, if you're thinking about multiple things where they're all easy to remove, what we end up with is basically everybody just donates their electrons, and it's kind of like a communal thing where this electron doesn't belong to any one element, but it's just kind of all over the place. So this is what we call the sea of electrons. And so the electron doesn't belong to any one nucleus. And instead, they're all kind of being shared. So a little picture here for you. Top left is ionic bonding. You can see there's a transfer of electrons, so we have ions. Top right is covalent bonding. You see we have no ions, and we have basically atoms joined together through bonds in which they're sharing the electrons. And then metallic bonding down here kind of gives us a little diagram of sea of electrons. So we'll go into much more detail for all of them. Today, we'll be focusing on ionic compounds and metallic compounds, and we'll save covalent for next time.